Now that we've established that this is most likely to be an explosion, the next question is, what's the likelihood that this is a naturalistic explosion versus this being a preset explosive device? The first reason why it's so unlikely that this would be air pressure that caused this, and this reason is particularly clear from this angle, is that as far as the top part descending into the bottom part is concerned, there's very little of that happens prior to our flash going off. The thing to remember, first of all, is that the descent happened very quickly, over 12 seconds roughly, which is, as even NIST themselves state, essentially equivalent to freefall. When we see the descent happening, it's going to be clear that it's occurring. So as we watch here, there is virtually no downward movement. There's some tilting that happens in the top part of the building. So this line, we can see it tilting this way a little bit, that way. But as far as downward movement, there is a little bit, but it's highly minimal. It's just beginning to move in that direction, and picks up speed dramatically once our flash goes off. So I was just scrolling between the beginning of the clip and the flash. You can see the flash go off there, and as you can see, again, very minimal movement. And now once the flash goes off, then I'm scrolling just as fast, and really here, only here, is when the descent really picks up speed, really begins to take place. So again, very minimal movement, and so the possibility that this minimal movement would have caused an air pocket so strong that it would have burst its way out of the corner, which is a very strong part of the building, one of the strongest, if not the strongest altogether. The idea that this would have caused, that so little movement would have caused such a strong phenomenon to take place is highly unlikely. Moreover, this ejection is happening again right in the strongest part of the building. So the next argument is that even if this were an air pocket, even if this were air pressure from the comparatively slight movement that occurs in the building prior to the flash going off, this pressure would be far more likely to find a much weaker area to escape from, a window, not the corner. So the question we need to ask now is, well, how do we know that this pressure is busting out of the corner? We can see it in the other angle. It's certainly very close to the corner, but what if that's an optical illusion of some sort? So again, it's certainly very close to the corner. We can say that with a very high level of certainty. But is it the corner or is it not? So another strong argument for the idea that this explosion did not make its way out of the window is a third angle that I'm going to show you now. We see that up to the point of, or down to the point of impact, as far as the corner is concerned, there's the expulsion of the debris and the warping of the entire corner, the line of the corner. There is very little. I mean, we see some aliasing, some pixelation, but the corner is quite consistent until the explosion happens. So explosion, and then the debris shoots out. So with those factors in mind, we're going to look at a close-up angle, which does not show us the flash because it's too low, but it does show us a very clear image of this corner coming down. And so we're going to see that warping that we see here. So again, straight corner, quite a straight corner, aliasing, video artifact, nothing that tells us in any particularly strong way that the corner is damaged until the ejection, and then we see quite clearly that there is warping going on in that corner as it descends. So with that in mind, let's look at this second angle. Again, we don't get to see the flash or the ejection, but we do get to see the aftermath. So this is the regular frame of what this angle captured. Again, we don't see the explosion, but we do see that the corner is quite straight. that entire perimeter of the corner of the building is quite straight as it comes down. There's no real damage until this area, which is clearly associated with a white smoke or debris that's coming from it. So other points to keep in mind here are as follows. First of all, as this damage enters the frame, so we see this damage here. Now let's track it back and see what is the earliest point where we see the damage in this particular frame. So that would be about here, right? That's when we see the earliest sign, that earliest little bit of white smoke or white debris that's associated with that damage. Again, quite clearly associated with that damage. So what does this tell us? So first of all, the amount of debris getting ejected as the top part of the building descends into the bottom part, there's relatively little of it compared to what happens as the building continues, the top part of the building continues its descent into the bottom part of the building. So all that debris is shrunk to quite a minimal size by the time that damage enters the frame. So that tells us that already tells us that the damage was done fairly early into this descent. Now, moreover, the fact that the damage is quite static by the time it enters the frame. We're not seeing any kind of violent puffing out of debris. The damage is quite again static by the time it enters. That tells us that even by the time it entered the frame, which is, as we established already, quite early into the collapse, the damage took place well before that even. So again, that tells us that even more so that the damage took place, much as our explosion that we've been tracking, took place very early into the building's collapse. Now, having a look at this footage in real time, we can also establish that, moreover, there isn't any it's not a very violent crashing of the top part into the bottom part. It's rather, it descends, the top part descends into the bottom part rather smoothly, which moreover makes it even less likely that this grotesque smoking damage would have been a result of some sort of crashing, a violent crashing of the top part into the bottom part. So now that we took a look at that, the other point that I want to make here is that the tilt of the top part of the building as that damage enters the frame in our close-up footage. So the tilt of the building that we can see here as the damage enters the frame is quite telling as well. It helps us match, because this angle is very similar to this angle of view. The tilt of the top part of the building as the damaged area enters the frame can help us match what we see here with what we see here, and it helps us discern whether the damage that we're seeing, how likely the damage we're seeing is to be the result of that explosion. So tracking that, we see that there is some minor tilt that happens in the top part of the building when the explosion takes place. Right? Now, as the explosion takes place, as there's that debris that jets out, as we see some warping in that corner, we can track how when this part where the damage takes place meets this part where the building splits into two and the top descends into the bottom. When this part becomes closer and closer to this part, about here is when this damage that we're interested in would enter the frame of the close-up angle that we were looking at earlier. So let's track what the tilt of the top part of the building is when there is that much descent that takes place. So let's have a look, frame by frame, moving forward. So we see that debris puffing out. Let's go backward a little bit. So we see the flash, then we see the debris that follows, we see it descend, we see it descend some more. So about here is when the damage and the damage that we're interested in and the split in the building become close enough to each other that we would expect to see them from the other angle, the close-up angle. Now, the tilt in the building is quite dramatically different. I mean, it's not a huge difference, but it's a dramatic difference between this tilt and what the tilt was before the explosion took place here. So we expect in the other footage to see a similar change in the tilt of the top part of the building by the time, if that damage coincides with this explosion, we expect to see a similar change in tilt by the time that damage enters the frame, which is exactly what we see. We see the top part is quite level by the time the footage rolls. Then we see a little bit of tilt, which is about when that explosion would have taken place. And then we see that about that same degree of tilt as that damage enters the frame, just as we would expect. So again, all this tells us with a very high degree of certainty that this damage is unlikely to be anything but the effect of that explosion, especially since, once again, we're not seeing any damage to that corner, virtually any damage at all, until that easily discernible, grotesque, smoking damage enters the frame. So my argument is that this is most likely the effect of that explosion, because again, it's perfectly straight as it comes down. The corner is undamaged until the area where we see that white smoke coming out of, that debris cloud. So this is most likely to be the result of that explosion, which tells us that the explosion escaped not from a window near the corner, but right out of the corner itself, the strongest part of the building. So again, highly unlikely to be merely air pressure, because again, minimal movement in the building and air pressure would find a weaker spot to come out of than the corner itself. And as we can see, the damage to the corner is quite extensive. And again, the official narrative doesn't allow for such explosions. It should have been just the impact of the collapsing building that caused that damage. So again, most likely to be that very explosion that caused this grotesque damage to the strongest part of the building. This is one of the things that tells us that this damage was caused by not just an air pocket, but by a very strong explosion. Again, due to how strong the corner is, how smoothly the top part descends into the bottom part, and how well the damage due to the explosion matches up with the damage that we see in this close-up frame, especially considering the similarity in the tilt of the top part of the building that occurs by the time that the damage that we're interested in enters the frame here, compared to the other shot where we're looking at. So the next argument is the color of the flash. As we can tell from this cityfire.co.uk website, which is a legitimate source, one way I like to confirm legitimacy of a website is to see if Wikipedia uses it as a reference, which is the case for this website multiple times in various Wikipedia entries. As you see in this emergency exit entry of Wikipedia, under references, number 3 is our cityfire.co.uk resource. So the source is highly likely to be legit here, and they have this flame color temperature guide, which tells us which colors of a flame are associated with which temperature. So I isolated the color that we're dealing with here of this flash, i.e. flame. This is it here, which, as far as our color chart is concerned, our flame color chart, it's somewhere between, I would say reasonably somewhere between 1400 and 1500. 1300 at the absolute lowest, but that's a huge stretch. The color is obviously here much closer to the 14 or 1500 mark. So the following excerpt from NIST's frequently asked questions about the NIST Twin Tower investigation. question and answer number 15 tells us about what maximum temperatures the official narrative can account for. And as they state, in no instance did NIST report that steel in the WTC towers melted due to the fires. The melting point of steel is about 1500 degrees Celsius. Normal building fires and hydrocarbon, e.g. jet fuel fires, generate temperatures up to about 1100 degrees Celsius, and that they tell us NIST reported maximum upper layer air temperatures of about 1000 degrees Celsius in the towers, and they give us a reference from their full investigation. So the upper layer air temperatures are the hottest part of a hydrocarbon or building fire. So basically they're telling us that their narrative cannot account for temperatures of higher than 1000 degrees Celsius. What our color chart tells us, however, is that this flame is, once again, 1400 to 1500 degrees Celsius, or 40 to 50% hotter than the official narrative can account for, which is obviously too much heat to leave unaccounted. This tells us that this couldn't have been just a regular building fire that was being spat out. It would have to be something quite a bit hotter. The next question for us to ask is, what if this color that we're seeing is not representative of the actual flash, but is a result of incorrect camera exposure? Basically, that the image was overexposed is how this would happen. The image would be overexposed, and a duller fire would appear brighter as a result. We can rule this out using NIST's own investigation. Let's take this excerpt from said investigation to see why that is the case. So, the intense fire in the northeast corner opening of the 81st floor is still present. An unusual flame is visible within this fire. In the upper photograph in figure 944, a very bright white flame, as opposed to the typical yellow or orange surrounding flames, which is generating a plume of white smoke, stands out. Now, note that when we looked at the close-up of the corner after the flash went off, we also saw what looked very much like white smoke still coming off of the damaged corner. Now, the intensity of this flame is considerably brighter than normal flames, is the other part I have highlighted there. But the most important part here is what they call a very bright white flame. So let's take a look at this figure 944. This is a close-up of said figure. So first of all, we can tell that this is a flame about as much as we can tell that this is a flame. It's basically a bright circle. But it's generating smoke, which again we have very good reason to believe that the other flash did as well. No other reason really to we don't really see the details of the flame. We can just tell that it's a very bright blob of light. So this is what NIST call a very bright white, which is indeed brighter on the surface of it if we just take the color of the flame. So if I zoom in on that bright blob, that phenomenon that NIST has pointed out right here. So what the color that we get is, so this is it here, it is a slightly brighter color. It's not as easy to tell on this side-by-side shot, but when we take the colors themselves, we can see that it is considerably brighter. But the interesting thing here is the question of exposure, of how exposed each of these flames is answered by the brightness of the adjacent columns. So these are the columns of the building, these are the columns of the building, and these are the columns of the building. So as we can see, this image is much more overexposed because these columns are blown, the highlights are blown way out, whereas here they're well under control. So the difference in the flame is this, in the color of the flame, but the difference in the color of the columns is this. It's much more stark, which tells us that this flame on the right is very much as bright as this flame on the left. So our flash is actually, even NIST themselves would call this flame that we're seeing, a very bright white flame. So no, it is not a question of exposure. It's not that this image is overexposed. It's actually well underexposed. It's that the freaking flame is that bright. It's just that bright. which tells us that this explosion flame is just that hot, which in turn tells us that NIST's official explanation cannot account for it. It's highly unlikely to be some sort of regular building fire flame. We can further ascertain this reality from NIST's frequently asked questions as to the Twin Towers investigation. So number 6, that's the entirety of it here. What caused the collapse of WTC-1 and WTC-2? As we can see here, there's two main points. 1, 2. There is no 3. 1 boils down to the impact of the planes, and 2 boils down to the subsequent unusually large number of jet fuel ignited multi-floor fires, which, importantly, reach temperatures as high as 1000 degrees Celsius. So the 14 to 1500 or higher degree flame that we see in this explosion is not something that the NIST explanation, the NIST investigation can account for. Moreover, as we could tell already from the previous excerpt, the jet fuel ignited fires is the second factor that, according to NIST, the NIST investigation, caused the collapse. Not jet fuel, but jet fuel ignited fires. There's a very good reason why they put it that way. As we can read in no uncertain terms in this particular NIST document, they state the jet fuel, which ignited the fires, was mostly consumed within the first few minutes after impact. The fires that burned for almost the entire time that the buildings remained standing were due mainly to burning building contents and, to a lesser extent, aircraft contents, not jet fuel. So, unequivocal statement from NIST. And this is the Shyam Sunder authored, William Grosshandler co-authored NIST findings on the World Trade Center fire and collapse. Shyam Sunder, of course, being the head NIST investigator. Moreover, what makes the jet fuel possibility even less likely yet is just the simple fact that the plane entered here. The explosion took place here an hour after impact, which tells us that in order for this explosion to be accounted for by jet fuel, the jet fuel would have to, post-impact, have made its way all the way up here, waited there for an hour, and then exploded just as the building began to come down. You know, a non-starter. Another non-starter. Aircraft contents, same thing. The idea that some other explosive part of the aircraft would have, upon impact, traveled all the way up there only to explode an hour later. Again, an exceedingly remote possibility at best, which again tells us that this was most likely an explosive device going off, because the amount of intellectual tap dancing we have to do, the sheer weight of improbability that we have to swallow in order to accept that this is some sort of naturalistic explosion is so enormous that just the basic scientific principle of Occam's razor tells us that we have to accept the far simpler, the far more direct, the far more likely possibility that this is indeed an explosive device going off, helping bring the tower down, as was done in 1993 when a bomb went off, an explosive device went off, and an attempt was made to bring the towers down. So this kind of purposeful attempt to bring the buildings down via explosives is moreover not even unprecedented. So I'm gonna end here by reading you guys a part of a 9/11 chapter that pertains to a book I'm writing. The bombing in question here is the bombing I just mentioned. So the day after said bombing, when there were lingering concerns that one or both of said towers may yet collapse, a reassuring article entitled "Towers Engineered to Withstand Jet Collision" was published by the Seattle Times. Pertinent excerpts. Quote, "Engineers had to consider every peril they could imagine when they designed the World Trade Center 3 decades ago, because at the time the Twin Towers were of unprecedented size for structures made of glass and steel. We looked at every possible thing we could think of that could happen to the buildings, even to the extent of an airplane hitting the side," said John Skilling, head structural engineer. Skilling, based in Seattle, is among the world's top structural engineers. He is responsible for much of the Seattle downtown skyline and for several of the world's tallest structures, including the Trade Center. Concerned because of a case where an airplane hit the Empire State Building, Skilling's people did an analysis that showed the towers would withstand the impact of a Boeing 707. Our analysis indicated the biggest problem would be the fact that all the jet fuel from the airplane would dump into the building. There would be a horrendous fire. A lot of people would be killed, he said. The building structure would still be there. Skilling, a recognized expert in tall buildings, doesn't think a single 200-pound car bomb would topple or do major structural damage to a World Trade Center tower. The supporting columns are closely spaced, and even if several were disabled, the others would carry the load. Skilling's analysis proved correct. Despite the fact that the explosion which ripped through the parking garage of the World Trade Center was caused not by a 200-pound bomb, but by a much more powerful 1,500-pound bomb, creating a crater 200 feet by 100 feet and several stories deep, and despite the fact that the conspirators had intended for the bomb to topple one of the towers and hoped that it would crash into the other, bringing them both down, despite all this, all WTC buildings remained standing throughout the entire explosion, cleanup, and repair ordeal. The side note here being that the above article ends with Skilling saying, I would imagine that if you took the top expert in building demolition and gave him the assignment of bringing these buildings down with explosives, I bet that he could do it.